The wave transverse question. First consider the fourth question, right? Certain length of wire when vibrated with the another sonometer wire produces 2 beats per second. Certain length of the wire. Here certain length of the wire. There is a certain frequency wire. The frequency say F. When vibrated with the another sonometer, this sonometer wire, in 2 instances, right? First instances, its wavelength length 220, another instant 120. Two instances, the frequency difference 2 hertz. That means beats frequency 2 hertz, right? Yes, this is the permanent sonometer. These are 2 sonometers, right? First sonometer frequency F, another sonometer F plus 2 and F minus 2. Why? Here consider this length, this position, right? This waveform. Here I choose fundamental, right? Fundamental. Here L is equal to lambda by 2. From this F is equal to V by 2L. Here the question says tension same for both instance and the mass per unit length is same. So Vf inversely proportional to L. So L increases, frequency decreases. So if L is equal to 120, frequency F plus 2. F is equal to 122, frequency is equal to F minus 2. So apply these 2 instances, F plus 2, 120, this one. Then finally, like this, the final answer F is equal to 242 hertz. Okay, 242 hertz. Here the question says the tension in both occasion they were made to vibrate at the same overtone. Same overtone means if it's fundamental, here also fundamental. If it's first overtone, so first overtone means 2 waveform. Okay, that is the answer. This is a 1994 question, right? Question. A violin string of length 0.04 meter tuned to a fundamental frequency for 480 Hz. How much string must be shortened to raise the fundamental frequency 600 Hz? This is a fundamental frequency 480 Hz, length 40 cm. So we have to raise the frequency. Wavelength should be small length, right? So this one shortened length. How to find? Already we familiar. The F is equal to 102L root of T by M. That is the fundamental frequency. So where tension T velocity is same. So F inversely proportional length. So 480, 40. 600, this one 600 hertz length. So find the L. Here by using this simplification, where you can find L is equal to 32 centimeter. 32 centimeter. So 32 centimeter. Already 40 centimeter. Here 32 centimeter. So answer 40 minus 32 is equal to 8 centimeter. That is the answer. Number 7. So 7. 2 steel wires string A and B the same length same, and the subject to the same tension same, length same, tension same, have the fundamental frequency F1, F2, the ratio of the diameter. Here that is the fundamental frequency from here TA by rho, phi A mean cross section area pi r square, R is equal to diameter d by 2. So that is the final answer. Frequency depends on tension, diameter and length and density. That is the fundamental frequency. That is the fundamental wavelength frequency F. Okay. So F inversely proportional diameter. So first instant F1 diameter dA. F2 frequency diameter dB. So here after that dA or dB is equal to F2 or F1. The answer F2 or F1. Then 8th question. the velocity of transverse wave in a stretched string depends on. The velocity depends on V is equal to T by M, root of T by M. Tension depends on tension, cross-section area or diameter and material. So in this question, depends on tension. So answer, fourth answer. Right? Then ninth question, question number 9. The frequency of the fundamental note of transverse wave of stretched wire 1 meter long, length 1 meter, frequency 320 hertz. That is the fundamental frequency. That is the fundamental frequency. The second wire of the same material same, density same, length same, but under the same tension, but they have the diameter, only diameter difference. So fundamental frequency equation here already mentioned here, that the 7th question, this is the answer, fundamental same question. So for frequency is equal to this one. So frequency here in both cases, frequency depends on diameter only. So F inversely proportional to diameter. So first instant diameter D, frequency 320 hertz. Second instance diameter 4 times is 4 diameter, 4D, if first instant D, second 4D. So frequency F by 4. F inversely proportional D. If D increases, F decreases. 4 times diameter increases, frequency 4 times decreases by 4 times. So the answer 80 hertz. Okay, first 320 hertz to, if diameter increases, frequency 80 hertz. That is the question number 9, 1998 year. That's all.